All right, so for number 9, this is the position function. So let me get that written down here. And number 9, what is the total distance the particle has traveled in 8 seconds? So you need to make a chart with time and position for the first 8 seconds. So I'm going to make a chart for time and position, and I need to include 0 and 8, and then I also need to include any times the particle stopped, and that would be when velocity is 0. And so that was actually the answer to question 8. So you know what, let me just go ahead and do question 8 as well, because I'm going to need it. 8 was asking when this particle was at rest. So that would be velocity equals 0. So velocity would be 3t squared minus 18t plus 24. And I'm going to go through and divide by 3. And then factor. So that is going to split, I'm sorry, I have this hole in the paper here. That's going to split t minus 2, t minus 4. All right, and so that is going to give us time 2 seconds and time 4 seconds. So that was the answer for number 8. And so when we go to do number 9, I'm going to use those 2 times as well. So we need the starting and the ending time, and then whenever the particle stops. And so we're going to plug those into position, which is this right here. So if we plug in 0, we're going to get 1. And then I would use my calculator for the rest of these, and just for the sake of time, if you plug 2 in for t here, and you could use your calculator, you will get 21. If you plug 4 in for time right here, you're going to get 17. And if you plug 8 in for time, you're going to get 129. So drawing a picture of what the motion is going to look like, we start at 1, and then it goes to 21, and then back to 17, and then up to 129, so all the way out here. This is obviously not to scale. It's just a picture so you can get a visual of what's happening. And so we're going to add up all of the motion. So if we go from 1 to 20, if we go from 1 to 21, that will be a distance of 20 feet. From 21 back to 17 will be a distance of 4 feet. And then from 17 up to 129 is, I gosh, what is that, 112 feet? And then I'm going to just add all that together. And so that is 136 feet. All right, and then I'm just looking back at the chat. 5, 6, and 7. So yeah, they all kind of go together. So I don't mind doing like a cluster of problems there. All right, so on the front page, the position function is t cubed minus 3t, and 5 is asking for the total distance traveled in the first 5 seconds. So that's really similar to the one we just did. So I'm going to make a chart for position. We want the first 5 seconds, so 0 to 5. Yeah, did you put a 21 here instead of a 20? If you did, if it makes you feel any better, you weren't alone, and I only took off half a point for it. If you start at 1 instead of 0, it'll put you off by 1. Don't feel bad. It's like it just happens. Okay. All right, so we want 0, we want 5, and then we also want whenever the particle stops. So I'm going to have to set velocity equal to 0, which I'm sure I asked you to do that in some other problem. Yeah, number 4, you would have had to do that. Set velocity equal to 0. So this velocity would be 3t squared minus 3. And so we're going to add over the 3 and divide by 3. And so we get time 1 second. And so I'm also going to need 1 on my chart there. So sorry, I know you didn't ask for 4, and like up here, I know you didn't ask for 8, but I had to do those questions in order to get to part of what I needed here. So we're going to plug 0, 1, and 5 into position. So if we plug in 0, we're going to get 0. If we plug in 1, this will be 1 minus 3, so -2. And if we plug in 5 cubed, that'll be 125 minus 15, so 110. And so again, just to make a visual of what is going on here, we're going to start at 0 and then go to -2 and then up to 110. So from 0 to -2, that's a distance of 2. And then from -2 up to 110, that would be a distance of 112. So we get 114 feet. All right, so number 6, still using the same information as 4 and 5 here. Number 6 is asking, when does the particle move to the left? So here, back in question 4 is when we looked at that. We would make a number line for our velocity, and 1 is the time that's going to have to go on there. That's when the particle's at rest. And I'm just going to test numbers in these parts of the number line to see whether I get positive or negative. So if we try to plug in a half to this velocity, a half squared would be a fourth, times 3 would be 3/4, minus 3 would give us a negative result. And then if I plug in a bigger number, like if I plug in 2, 2 squared is 4, times 3 is 12, minus 3 is 9, which is positive. So the particle moves to the left or in the negative direction, and then to the right or in the positive direction. So number 6 said, when does the particle move to the left? Justify your answers. So it would be from 0 to 1. So it moves left, 0 to 1, because velocity is negative there. And just to talk a little bit about the justifications, because it sounds like I'm being super picky, but they actually won't give you credit on the AP exam if you aren't really particular. You can't say because it is negative, they won't take pronouns. Because I had some people, when they were talking about speeding up and slowing down, they would say they are opposite signs. Like you can't say they, you have to say velocity and acceleration. So you have to reference the function that you're talking about, be it velocity or acceleration or both of them. Also, you can't say they are opposite or they are the same. You have to say opposite signs or the same sign. Because technically they are opposite means like they are literally opposite, like 1 is 2 and 1 is -2 or something like that. So it's technically not an accurate statement. So they are pretty picky about that. So just be really careful, write it exactly the way I've shown you to get full credit there. Yeah, and I'm just going through the list that you guys have put in the chat here in the order you guys are writing them. So I will get to all the ones that you've typed in there. All right, so number 7, when is the particle slowing down? Justify your answer. So we already looked at velocity, we just need to look at acceleration as well. For speeding up, slowing down, you need to look at both. So let me get this acceleration function. Velocity is right here. So acceleration is going to be the derivative of that. So that would be 6t. And no matter what you plug in here, if you plug in a number bigger than 0, this is always going to be positive. You'd have to plug in a negative number, and we don't do negative times. That's going to just have to always be positive. So 7 was slowing down. That would be right here. So we would say slowing down 0 to 1 because velocity and acceleration are opposite signs there. And so once again, you can't say they or the signs, like you have to say velocity and acceleration. And you have to say opposite signs. If you leave out signs, they're not going to give it to you. Again, I know that I feel bad because it sounds like I'm being so picky, and it's like, but Ms. Cole, you knew what I meant. I totally get it. They won't give you credit for the justification on the AP exam, so I have to, go with how they grade it. All right, let me scroll back to the chat here and see what else you guys had. All right, so I did 5, and then 13. All right, so I'm gonna need the graph, the velocity graph that was given here. So just hold on 1 second while I draw this. It will not take me very long. We're gonna need to be able to look at this. All right, so this is your velocity from 0 to 8, and you're being asked, when is the speed increasing? So that would be speeding up. So that is gonna be when velocity and acceleration are the same sign. So I'm gonna make a number line for my velocity and acceleration. I'm gonna need to put on there 2, and then 4, and then 6. So basically all the even numbers here. And when I'm putting in the signs, this is the velocity graph. So velocity is positive when this is above the x-axis, negative when it's below. So you have positive from 0 to 2, negative from 2 to 6, and then positive from 6 to 8. And then acceleration is the slope of velocity. So now we're looking at increasing and decreasing. So acceleration is negative from 0 all the way until 4, and then positive from 4 to 8. And so this said, when are we speeding up? Speed increasing, that would be when these are the same sign. So we would say from 2 to 4, and from 6 to 8, because velocity and acceleration are the same sign there. Right, and then someone said 12. So let me go back to 12. 12 also uses this graph, and it said over what time intervals is the particle moving to the right? So moving to the right would be when velocity is positive. That's when this graph is above sea level. So that's going to be from 0 to 2, and also 6 to 8. And the reason is because velocity is positive there. Also, I just thought of this too. I have to remember to say all these things to all of my classes. I can never remember what I've said to whom. I didn't mark off for this, but I had just a few people do this. They put a plus sign instead of like an abbreviation for positive. I'm not 100% sure they'll allow that on the AP exam. So I'll take it. I don't care. I know what you meant. But when you go to take the AP exam, please just go ahead and do this. You don't want to risk losing points because you didn't like write it out in words, because they view it as essay writing. It's like you're writing a math essay, essentially. It's like a sentence. All right, and I'll maybe do one more if you guys would like to pick one more. Are we all good? Cool. All right, I'm gonna go ahead and stop the recording, okay?